Okay, one big caution, listen. You have got to read slowly. It just keeps happening. Like I have people ask me for help, and all I have to do is tell them, you read too quickly, and then they'll answer their own question. So on the actual test, you have to have the habit of reading slowly. Look up. You'll see questions that will use the word differential equation, like here. Just because they say differential equation doesn't mean you're trying to solve the differential equation. Like, unless they ask you to solve the differential equation, don't solve it. I've come up with an acronym to help you remember these steps. The acronym is nothing special, but it does seem to help. How you pronounce the acronym depends on your point of view. Some people say Saki, some people say sassy. I prefer the sassy method. It sounds a bit edgier. I don't know. It's about as edgy as I get. So S stands for separate. That's what we did here. So this was the separation of variables step. A stands for find the antiderivative of both sides of the equation. That got us to here. C is for I wanted it to rhyme, so I call it separate, anti-differentiate. I had to make up a word. Constantate.
I like it.
Find the constant. I is for isolate. Get the Y alone. So. Okay, look at number 2. Number 2 says, write an equation for the line tangent to the graph of h at x equals 4. Whenever you see the words, write an equation of the line tangent, you should draw my favorite picture, like this. A bit of review here. So it says an equation for the line tangent to the graph of h, so this is h. X equals 4 is right here. I don't know this value, but I can use a symbol to represent the value. So like that. Question? And the goal of the problem is to write the equation of the line that is tangent. This should feel like review from Unit 3. That's really bad. That's better. That's still not there.
No, just make the dot really big and then it
yeah,
goes through it.
Cheating. Yeah, I'll just wait for a moment here. There we go. Perfect. Okay. This equation is going to be y equals mx minus x1 plus y1. Question? Raise your hand, please. I want to pay the whole room. Feel free to talk if you need to. What's the purpose of that equation? Hands up. Hands, please. What is the purpose of that equation? We need more hands. Talk until we have more hands.
Oh no. That's great.
Hands, please. Come on. What's the purpose of that equation? Go, Mallory. Hold on. Raise your hand if you would have answered what Mallory answered. Oh yeah, sorry. She said find all the tangent slopes on the curve of h. Hands up if you would have said that. 2 points. Mallory gets to take it. You can't say it better. That's the purpose of that equation. It also finds all the y coordinates on each prime, but look, I need the slope of h right there. So I need to plug in an x value of 4. So this is FRQ, so I want to make sure I have good notation. So I write h prime of 4 is equal to, I always use parentheses when replacing a variable. (16 minus 2 is 14. 14 over 4. You don't have to reduce. You can if you want. You do not have to. Question? So hands up, what's 7 halves? Yeah, I gotta look up here. Everybody look. You have to be really careful. 2 points for Matt, but he said something that's really common, which is you do a little work and then you say, "Oh, is that the answer?"
No, I meant tangent slope.
Oh, yeah, just checking. Okay. Yeah, don't fall into the trap of like, I did some work, I'm done. No, you got to answer the question. So hands up. What is 7 halves? Come on, think with me. Don't just watch. What is 7 halves? Tangent slope of what? Right idea, the words are coming out a little wrong. This is the tangent slope of h, because h has a million different tangent slopes, at x equal 4.
Which is equal to the line.
Which is what?
Equal to the line, right?
No.
No?
That is simply the slope of the line is not equal to the line. Come on, look at me. Okay, you really have to up your precision. Like, this problem is full of, well, it's full of, like, people make a lot of mistakes because they just get too casual. For example, they'll say, oh, this line, that's the derivative. No, the line isn't the derivative. The line is this equation. Like, this is the equation for finding all the xy pairs along that line. This is the slope of h at this spot. Therefore, 7 halves is also the slope of that line, but it's not the line.
Wait, are we finding the red line or are we finding the green?
You tell me.
An equation for line tangent to the graph of h. We are finding the green line.
Yeah, we're finding the green line.
So would you put 7 halves for m?
So m represents the slope of the green line. We now know that m is 7 halves. And look up, come on. Getting everybody thinking, not just passively listening. As I say all the time, if you want to just passively listen, stay home and watch the video. But you'll not get nearly as much as if you think with me. So I know the slope of the line. X1, Y1 represents a point on the line. So I have the X1, that's 4. I need the Y1. I just found it. Raise your hand, please. Talk if you want, but don't shout it out. Just raise your hand. What's the Y1? Let's go, Andrew. How many knew it? 2 points. Yeah, just I had to go search. Like, I'm looking for the value. I'm searching. Like, oh, they gave it to me. Big question. Okay, look at me. Come on, look up. Okay, we need to use this problem to illustrate another concept. Listen, we need to use this problem to illustrate another concept. So this problem is not asking the following question, but you need to understand this because it will happen on the AP test. They like to ask questions like this. They'll say something like, what is, or find, so what is or find the tangent line approximation? So they'll start out the question by saying something like, what is or find? Then they'll say the tangent line approximation, or they'll say the, what are the words that they use? Local linear approximation? They'll use words something like that. They, as always, will vary the wording. But what they're asking you to do is this. They'll say that find, or what is the tangent line approximation or the local linear approximation of h of, say, 4.1. Okay? And what they're asking you to do is really, really simple. Okay. Points for this. If I'm trying to find h of 4.1, just ignore the problem. I just want you to answer the general method. Like, generally, what is the method for finding h of 4.1 in any problem? Like, you used to read a problem that says find h of 4.1. What are you going to start looking to do generally to find h of 4.1? So talk to someone who has their hand raised so you can understand it as well. How do we find h of 4.1 in pretty much any problem? Like a simple way, not a complex way, a simple way of finding h of 4.1. Hands, come on. Show me some hands. Show me some hands. No one talking, silence, Mike. Plug in 4.1 into the equation of h. Hands up if you would have said that. 2 points, 3 for Mike. Look up. If I have an equation for h, and I plug in 4.1, I'm going to get a y value. What I will be finding is basically a point on the h curve. So we're going to assume that this curve is blown up very large, and right here is the point x equal 4.1, and h equals, the y value would be h of 4.1. Okay, that's how we would find h of 4.1. Question. When they ask for a tangent line approximation, they don't want you finding the actual value of h. They want you to find something nearby. So what we do is, instead of finding the dot on the red curve, we find the dot on the green line that is at the same x-coordinate. It's a really simple concept. You're using the tangent line, which is nearby the red line, to find an approximation for a value on the red. The idea is that in certain real-life applications, it is difficult to find the value of the red. You just can't. But if you can find the value on the green, decent approximation, depending on the real-life application. But this happens all the time in electronic circuit design, actually. Stuff that I used to work on. You can't really deal with the red curve. It's too complicated. But you can deal with the fact that you're close enough. All of you have experienced this, by the way. Raise your hand if you've ever taken any sort of audio system, and you've turned the volume up all the way, and you've noticed that when the volume is all the way up, it's louder, but it's also not as clear. Like, it's distorted. How many have experienced this? Okay, look. That's because the circuit has been designed following the green line, linear. But the actual amplifier follows the curve. And so when the sound is kind of in this region, it's pretty good because the approximation matches the curve quite well. If you turn the volume up too far, it starts to separate and it doesn't sound right because it's not amplifying properly. That's one cause of distortion, is this non-linearity of the system. Random trivia. Please.
So when we're trying to find the tangent line approximation, we find the points on the trees.
Yep. Listen to Hannah. Finding the tangent line approximation is no more complicated than. Instead of finding the point on the red, You just find the point on the green. But we now have an equation that can be used to find any point on the green. Parker, please.
So why wouldn't you differentiate that equation, that equation right there? Why don't you just get another equation for that and just plug in 4.1 in that equation and get the tangent slope for that one, recreate equation?
What you're saying is, why not just go find the equation for h?
Yeah.
In the problems case, it's simply because they didn't ask you to. They said to find an approximation,
Okay.
so they don't want you doing that. That's the test question.
Okay.
In a real life sense, what happens is, real life problems are of course more complicated than a classroom problem, and you can't always do that.
Okay.
So the best you can do is say, I'm just going to have to use the linear approximation instead. Does that kind of make sense?
Yeah, that makes sense.
It's a good comment. 2 points. So look over here. You have an equation for the green line. You just need to find the value of this equation, the y coordinate on the green line, when the x coordinate is 4.1. So all you have to do is this. Y equals 7 over 2, plug in 4.1, and then stop. That's it. You don't need to simplify, you don't need to do anything. Whatever that number is, that's a good approximation for this y coordinate, but the rules of the AP test say you don't have to work this out. So you don't. You just stop there. So again, reminder. This particular problem did not ask us to do the purple. This particular problem asked us to only do the blue, so we would have stopped at the blue. But had the question continued with something like this, we would have had to have done the purple as well. I just used it because they often go together. Question? Mike? Oh, stretching.